Continuing the preceding, we've broken our integral into two integrals. This integral we know, without the 2, to give us pi over 6. So what we're going to end up with is 2 times pi over 6, as we've seen a couple of times previously. Now let's concentrate on this integral here. We have then 2 times the integral from 0 to 1 times the integral from 0 to the square root of 1 minus x squared, and these are limits on y, so I'm going to say y equals 0, y equals square root of 1 minus x squared, because we're going to do the u substitution. So this is going to be times what? This is just the square root of u, and y dy is negative 1/2 du. And then we, of course, have our x integral on the outside. So these integrals break down to this. The rest of the process is fairly straightforward. So 2 times pi over 6 is pi over 3. Now, 2 times 1/2 is going to give us negative 1, so I might as well write this as negative the integral from 0 to 1. Antiderivative of u with respect to u is just 2/3 u to the 3/2. Evaluated between y equals 0 and y equals the square root of 1 minus x squared. And then that with respect to x. Substituting again u, which you recall was 1 minus x squared minus y squared. We get pi over 3 minus the integral from 0 to 1 of what? Well, let's bring the 2/3 out here. And then it's going to be the quantity 1 minus x squared minus y squared, which is our u quantity, raised to the 3/2, evaluated between now y limits of the square root of 1 minus x squared and 0. We wrote the y equal here and the y equal here because we had the u and we didn't want to lose track of the fact that these were limits on y, not on u. Now that we've substituted back, we recall, actually it wouldn't hurt to say this is between y equals this and y equals this. We can pretty much tell that from context, but it doesn't hurt to remind ourselves. Okay, so that gives us what? Pi over 3 minus 2/3 the integral from 0 to 1 of what? If I substitute square root of 1 minus x squared for y, I get 1 minus x squared minus the quantity 1 minus x squared, because y squared is just going to be 1 minus x squared. So that gives me 0. And at y equals 0, I just have 1 minus x squared to the 3/2 with respect to x. So my integral is pi over 3. At this point, my integral is pi over 3 minus 2/3 the integral from 0 to 1 of the quantity 1 minus x squared to the 3/2 with respect to x. How am I going to integrate this? We've seen this form before. What we did before, same thing we do now. It's like, it's not a square root of 1 minus x squared, but it's a integer plus 1/2 power of 1 minus x squared. We're going to use the same trick we used before. We're going to let x equal cosine theta, so that dx is negative sine theta d theta, and this integral is going to become the integral of 1 minus cosine squared theta to the 3/2. Now, cosine squared theta. 1 minus cosine squared theta is just sine squared theta. So our integral becomes pi over 3 minus 2/3 the integral, that's from x equals 0 to x equals 1. But now in terms of theta, this is going to be 1 minus cosine squared theta to the 3/2 is sine squared theta to the 3/2, which is sine cubed theta, multiplied by our dx, which is negative sine theta d theta. I'll put a sine theta d theta out here and take care of my negative by making this sign positive. So now we have pi over 3 plus 2/3 the integral from x equals 0 to x equals 1 of sine to the 4th theta d theta. Now, integrating sine to the 4th theta takes a few steps, and I'll sketch those steps, but I'm not going to go through them in complete detail. This is an integral that you learn to do in first semester calculus, and you can, of course, review the process. The end result of this integral is 3 pi over 16, and I should have said equals, plus is really kind of redundant, but it's not incorrect. Pi over 3 plus 2/3 times 3 pi over 16. Okay, well, the 3 divides a 3, so this becomes a pi over 8 and a pi over 3. Express those both as multiples of pi over 24, and we have 8 and 3, 11 pi over 24. And check my arithmetic on that. But I believe that's correct. Now I'll go through the details of integrating the sine to the 4th on another clip. But first, let's just check to see if this result makes sense. Okay, so we have a total mass, remember, because we've integrated the density over the region. We have a total mass of 11 pi over 24. Recall that our volume was pi over 3, which would be 8 pi over 24, implying that we have a density a little more than, well, between 1 and 2. If the volume, not sure I have room to write this here, so let me come on up here where I've got a little bit of blank space. So our final result the mass is 11 pi over 24. The volume from previous calculations is pi over 3, which equals 8 pi over 24. So that mass over volume, which equals the average density, is 8 pi over 24 11 pi over 24 divided by 8 pi over 24, and that just comes out 11/8. And if we want to put that in decimal, it's 1.375, between 1.3 and 1.4, but clearly the average density is between 1 and 2, and actually a little closer to 1. Well, recall our original density function was 1 plus y, and y values on this integral run from 0 to 1. So I hardly have room to write it here, having not planned very carefully, but consistent with the fact that 1 is less than, our delta is less than 2 on this domain. Now you can't read the word domain, but the point simply being that if y lies between 0 and 1, 1 plus y lies between 0 and 2, our density therefore lies between 1 and 2. And I think I just said 0 and 2. Y lies between 1 and 2, 0 and 1, so that 1 plus y, excuse me, so that 1 plus y lies between 1 and 2, consistent with our average density as calculated by the integrals.